Okay, so we're looking at parallel lines, which are straight lines, obviously. Excuse me. So I've got 3 black lines on the number plane there, and they're like, you could make them like train tracks. So they all go in the same direction, and they have the same gradients, but they have different y-intercepts. Okay, so each of these has the same gradient, but the y-intercept can change. Okay, so parallel lines are like train tracks. Okay, so copy that down and then come across. Okay, so just to use some symbols. So if the first line has a gradient of m1, the first gradient might be equal to 2. And if the second line has a gradient of m2, what we have to say is for parallel lines, the 2 gradients are equal to each other. Okay, so m1 equals m2. So m1 is the first line, m2 is the second line. So this is just some examples. They could be 2s, they could be 5s, but they're the same number. Okay. So in this particular one, I want you to find lines that are parallel to y equals 2x plus 1. So I'll give you a head start, but if you're not sure, then just when you're ready, just press play and we'll have a look. Okay, so we're looking at the gradient equals 2. So just remember, we've got y equals mx plus b. So the coefficient of x is the gradient. So we're looking for anything that has a 2 in front of the x. Okay, so that has a 2 in front of the x, so that is a parallel line. This has a 2, but it's in front of the y, so it's not. This has a 2 in front of the x, but what happens is this particular one is not. Just hang on, we'll just check. Move the y across, so y becomes positive. Move the 3 back, so y equals 2x minus 3, and so in fact that does have the right gradient, so that's parallel. And this has a 2, but there's no x, so that's no. So with this C1, we just had to rearrange it to make y equals, and just make sure that the gradient was 2. Just an example, like for instance, if I'd have had E, if I'd have had 2x plus y equals 3, y is positive, so move the x across, so y would be minus 2x plus 3, and then you've got a minus 2, so it's not parallel. So just got to be careful, it's just not a 2, but it has to be y equals 2x. Okay, so looking at harder problems with parallel lines, I've got to write an equation of a line that's parallel to y equals 2x minus 5, that A has a y-intercept of 2 and B passes to a particular point. So what we do is you take the information, gradient equals 2, doesn't always equal 2, but the last couple have been 2. So in A, we've got y equals mx plus b, m is the gradient, and b is the y-intercept. Clean it. Y-intercept. And so we've got the y-intercept is 2, so that means that this one would be y equals 2x, 2 from the gradient being parallel, and the y-intercept is 2, so that's the answer to the first one. In the second one, we've got y equals mx plus b, and this time we're given a point, so we substitute the point in. We need to find the value of the b value, so we've got, okay, that's the x, and that's the y, so we've got 3 equals 2 times 5 plus 10, therefore 3 equals 2 5s are 10 plus b, 10 goes backwards, so b equals 3 minus 10 equals minus 7, and so the answer is y equals 2x minus 7. Okay. So there's not much in the textbook on parallel lines, so I'm going to have 2 worksheets on Moodle, and the first one is exercise 709, just have a go at those questions, and the second one, exercise 7D, and have a go at those questions. Okay, thanks. See ya.